Hi everyone, welcome to today's Aiven webinar. Wait for buses, not insights. I'm Shu. I look after regional marketing here at Aiven and am your host for today. Before we start the webinar, I just wanted to give you some quick instructions on how you can navigate your screen. At any time of the webinar, feel free to send any questions that you might have in the questions or chat panel. Our presenter Dave will be answering your questions at the end of the webinar. Before I hand it over to Dave, I would obviously like to share a little bit about him. Dave is a staff solution architect at Aiven and is passionate about data, tech, and espresso. Me too. I have a coffee right here. He enjoys writing code, certainly a lot more than writing about himself, and has contributed to several open source projects in the big data ecosystem, including Apache Kafka, Arvo, HBase. I'm obviously not very technical and crunch. Nowadays, Dave does more talking than typing, having spent the best part of the last 8 years as a technical architect and consultant, traveling the world. I miss traveling the world and helping organizations of all shapes and sizes with their data problems. Thanks, Dave. I will hand it over to you.
Okay, thanks, Shu. Thanks for the introduction there. Hello, good morning, good afternoon, or evening, everyone, wherever you are. Our webinar today is called Wait for Buses, Not Insights, How to Build Data Analytics Pipelines Faster Than Your Morning Commute. And that idea of a morning commute might mean different things to different people now, especially in this remote working world. But even if your journey to work really only consists of a short trip downstairs from your bed to your desk, with a little diversion to the coffee machine along the way, maybe we can still have a go at beating that benchmark time. So Aiven, we're a software company. We're based in Helsinki in Finland, and we provide managed data services in the clouds. And I'll explain exactly what that means as we go, using a variety of analogies, including Lego and public transport. But if anything's still not clear by the end, then please fire your questions into the chat feature, and we should have time at the end to take a question or two. So I'll start by outlining some key principles that we'll focus on through the session today. DataOps and DevOps are similar in some ways, but different in others. They both have roots in agile development, and this idea of rapid delivery and continuous improvement is really important in both cases. So probably the most important principle today is this idea of delivering analytical insights to customers really quickly. I would talk from a couple of minutes to a couple of weeks, but really no more than that. And the other 2 points here on the slide really just help us to achieve this. So with DevOps, we have infrastructure as code, and in DataOps, we have data pipelines and analytics, also now defined as code and configuration as well. And these can fully describe what actions have been taken so far, what we can improve later. So define the creation of the data infrastructure, how it's set up, what workloads are running on there. The code might even be generated by the tools themselves. And the third and final point is this idea of enabling really easy experimentation. And what we mean here is that it's really important for our analytics team's members to be able to try out new ideas that they have really quickly in an environment that reflects their production setups, their production data. So what we need here is to be able to provide isolated, safe, but really ultimately disposable environments. You need to be able to throw this thing away and recreate it really quickly and start again. So the same tools, the same data as production, but maybe sanitized to remove some sensitive stuff like your customer information, but realistic on a smaller scale. I think these ideas can be shown quite nicely on this diagram of two pipelines that sort of meet in the middle here. So we have value going right across the top, and this is quite obvious, I guess. We've got data on one side flowing in. We've got some kind of production data pipelines in the middle, and ultimately what we would hope is we get some value out the other side for our business. But this innovation pipeline at the middle really is, I guess, what we'll talk about today. And it's the idea of having an idea. The word's already been used about what we might like to do. We've got a blank sheet of paper, an idea about a data set which we think looks interesting, and we need a place to play and develop and innovate. And this pipeline is that constant loop of idea to development and getting that through to production as quickly as possible, and then going back to square one with another idea of how to improve or do something completely new altogether. But what does this idea of data architecture even look like? So I've got this diagram here, which I've taken and adapted from a post on future.com. and it shows a unified data architecture. So you're not always going to need everything on this slide, but there's a good chance you'll have or need a fair bit of it. So multiple boxes on this diagram to make something useful. So we've got our data sources on the left, various analysis tools and outputs on the right. And in between the two, in the middle, we've got a whole load of complexity. So suddenly, if our goal is to start delivering quality insights within minutes, making it really simple to innovate in that space in the middle, and that's starting to look like a real challenge. So we do the only thing we really can do and start small and take this bit by bit and start building. So each component or service, really every box in that diagram I showed just now, that can be a powerful tool, powerful software in its own right. But if you've only got the one thing, like in Lego, if all you've got is a bag of orange 2x2 bricks, you're kind of a bit limited in the sort of things you can end up building. And the same idea with data. If all you've got is one kind of tool, one kind of database, of course, that places a limit on the kinds of pipelines and processing and applications that you can build and achieve. But one good thing, at least, if you've got well-defined interfaces, connectors, like on this brick and like we have in software, with APIs and the like, we're off to a good start, at least. And it makes building on top of that first block a little bit easier. Where we want to get ourselves to is some kind of a finished product. So an end-to-end data solution that we can use to start to generate some value, some insights. So we had a set of components before, and they fit together quite nicely, right? Quite logically. And now, like this completed car, we've got something that's quite stable and secure. All fits together really nicely. And even better still, pieces can be swapped out and new ones swapped in later and adapted as requirements change. And we start to have a better idea about what we might like. But how do we find the right pieces to build what we need to build? We can't go out to the shop and buy a box Lego set. A lot of the time, we don't get exactly the right pieces. We don't get that nice instruction manual. So we've got to go out to the marketplace and find some stuff that's really crowded and difficult to navigate. Every box on that diagram before has so many vendors out there. We were at Big Data London conference last week. The number of vendors with their stands and all the different products competing with each other. If I was a customer just walking around trying to make sense of that, it's not an easy ride. So the question is, what are we going to build? And the thing that we end up with, what's it going to look like? Is it going to look like something cobbled together by an 8-year-old or something like the work of a master builder? And then we'll move on to the idea of a stack. So this is going to help us out here. A stack is really just a collection of services that are known to work together well. So yeah, you can come up with one of these yourself. But really the idea here is we need to go down a more well-trodden path and use the learnings and the patterns that others have tried before us. They'll have failed, they'll have learned some lessons, and now we can pick up from that good work and not fall into the same traps. So of course, that's going to limit our options, but it's going to provide a lot more reassurance that the thing that we do end up building will work. There's some open source stacks for software development, really well known and really well defined, like LAMP and MEAN, Linux, Apache, MySQL, and PHP, for instance. But in data architecture, we don't really have so many famous stacks, certainly not as well defined as that. Probably the most well known is the modern data stack. That's not really telling us a huge amount, other than we're building around a cloud data warehouse. We might have integration, transformation, tooling alongside a BI system. And one main characteristic around modern data stack is that you'll end up with many tools from many different vendors. And although they're probably quite easy to configure and work nicely together, that's not going to come cheap, potentially. And that's a complex thing to manage, definitely from a commercial perspective, if not a technical one. So that brings us on to the question of managed services more generally, right? How much work do we actually want to do? So imagine you've got a journey to make. You've got a car and a driving license. You can just get in that car and make the trip. But if you don't already have those things, if you don't have a car, you don't have a driving license, think about the upfront investment of time and money you're going to need to make to put those things into place. And in some cases, that investment is very sensible. That will make sense. But in others, it definitely wouldn't. And then there are other options. So you can consider other options to move yourself from A to B. But I think even if you did have that car, the conditions of the journey you're about to take might make driving sound pretty unappealing, right? Maybe it's an 8-hour trip. Maybe you don't know the roads well, or you know the traffic's going to be savage and it'll be really busy and stressful to do that. So that decision to drive or not to drive really has many of the same criteria as to self-manage data infrastructure or to look for other alternatives like managed services. So maybe you don't have the skills, the experience, or the resource to take it on yourself. Maybe you've done that before. Maybe you've been there and done that and now decided that the time and effort you spent there could definitely be used elsewhere in a much more effective way. So what I think we need to do is choose along a few scales. I've got them on the screen here. So really, how much responsibility are we happy to take on for the management and maintenance of our stuff? How much freedom do we want to make them work exactly as we want them to? And things like, are we happy to share our systems? Are we happy that other organizations are on the same stacks that we are around the world? Or do our security policies dictate that's just not really possible? So we've got a few options. With a self-managed system, of course, like a car, like your own car, you've got ultimate freedom, but ultimate responsibility. So you can buy and build anything you like, but you are the one ultimately on the hook to keep it working. IaaS, infrastructure as a service, that's a bit like renting a car. So they've got a provider now taking care of the hardware, maintaining the hardware, but you still need to have the skills to know how to drive that thing. But also you've got the freedom to drive it wherever you would like, within reason. Platform as a service shifts a bit more of that responsibility away. So now you've got a driver who's working just for you, as long as you're paying. You don't really need to have an idea about how to drive yourself, but you just do need to know a little bit about where you want to go. And then finally, software as a service. This is like your buses, coaches, and trains. So these services are running on different kinds of hardware, right? Very powerful and quite specialized that you couldn't or wouldn't want to build these things or buy them yourself because it just wouldn't be economical. You don't get a lot of freedom anymore. You can't choose exactly where you'll go or how you get there. But as long as you're happy with the destination that's advertised on the front of that thing, you just buy a ticket and get on with your fellow passengers and you're on the way. So when we think about Aiven, I think we're on the borderline between PaaS and SaaS here. The Aiven services are all single tenant and do give some freedom of configuration, but you keep a lot of the simplicity of running in SaaS at the same time. So just to introduce Aiven a little bit more, this is our CEO, Oskari. He and his co-founders, 3 co-founders, started Aiven with this mission, to create the best managed service platform for data. They were all software developers and consultants, and they had a lot of clients who had these challenges. And they wanted to help their clients adopt open source software, but really wanted to avoid the burden of managing and maintaining all those services. They wanted the freedom to deploy on any cloud provider, but didn't want the hassle of constantly having to deal with the nuances of each provider, having to learn all these different tools and technologies all the time. And the problem back then is that they really wanted a platform like Aiven, but it didn't exist. So they went and built it for themselves. That was back in 2016. Fast forward a few years now, and this is the platform that we can offer to our customers today. So we've got a nice range of open source data infrastructure along the top here, all deployable, fully managed on the cloud provider of your choice, and they're shown along the bottom. And when we say fully managed, really it is as close as you can get without being a big multi-tenant SaaS or serverless product. So we've got all the automation to provision a dedicated service, just as you'd expect. But where other providers sort of hand over the keys and leave you to it at that point, this is where Aiven's operations staff will help you from day 2 onwards, actively monitoring and fixing any issues that arise, hopefully before you even notice anything went wrong. We're API first, and what that does is open up a really nice range of options for how you interact with us. So the console, just the GUI, is a nice way to get started. But if you're a shell scripter or a Terraform fan, then these tools are available, and that's probably going to be the option that you would prefer to use. So I'll dig a bit deeper into a use case at the moment, provided my connection holds up. And I'll show you how to build a real data pipeline using Aiven. But first, just to quickly introduce you to another Finnish success story called DigiTransit. So this is a platform, really cool platform built by the Helsinki Regional Transport Authority and some of its partners. And what's unique about this is that this itself is fully open source. So you can go grab the code for this, run your own journey planning application, if that's what you feel like doing. And they provide a really nice set of APIs around mapping, geocoding, some near real-time data feeds for service alerting, trip updates, and vehicle positions. And that's the data feed that I was interested in. So let's see how we can grab that vehicle position real-time feed, build a pipeline quickly on Aiven, and use those events to learn something new about the state of public transport in Finland. So hopefully you remember the diagram from before. Here it is again, but highlighted now to show the components that we're going to use for our solution we'll build. So the input data source on the left-hand side is this third-party API provided by DigiTransit, I just mentioned. And then we'll use an event streaming platform powered by Apache Kafka. We've got stream processing with Apache Flink, and our real-time analytical database will be powered by ClickHouse, all running on Aiven. And here's a nice map. Here's the full map of what we're going to build. So outside of the core services we just mentioned, we've got the Kafka Connect framework, which we'll use for subscribing to that DigiTransit MQTT feed. We'll also have, along the top here, a bit of a extra line. We've got M3DB as a time series database and a Grafana instance for dashboards. And all that part is doing is really collecting all the technical metrics from our Kafka cluster to allow us to monitor the state of the system, but really our pipeline to make sure that that's healthy. We can check out things like the incoming message rates, consumer lag, and start to set alerting thresholds for those. If you drop into the Aiven console, this is what you'll see. You don't have a service, and this is where we'll go and create our first thing, and you'll see the full range of open source managed services that we offer. So of course, they're the ones we're using so far, but others to choose from, as we saw before, like OpenSearch, Apache Cassandra, and Redis. They're building out all different kinds of applications and use cases. And I chose to run my stack in GCP this time, but you're free to run this thing on the cloud provider of your choice, as I mentioned. Only ClickHouse, as it's in beta at the moment, is limited to AWS and GCP. But soon that'll be released to the remainder of the cloud platforms that are available to us. Let's go a bit deeper into the pipeline then. Inside our Kafka Connect service, what we'll do is run the MQTT source connector from Stream Reactor. And there's no custom coding here required really at all. There's just some minimal configuration to point to the correct endpoint, tell it where that is, pass in the topic details of the MQTT topic we want to subscribe to, and then let the connector know what data format we'd like it to write. So I've chosen JSON just to keep it simple, but Avro is an option here as well. And then when that's running, we get records like this on the top right here appearing on a Kafka topic. So we've got operator IDs, vehicle IDs, speeds, headings, locations, there's latitude and longitude, a variety of other fields that we can start to look into. But there's a couple of things about this that I don't really much like. The first is that the whole thing is wrapped as a JSON object called VP, standing for vehicle position. And the second is that ID, operator ID, doesn't really mean much to me. I'd perhaps like to know the transport operator's name instead. Just a quick aside about Terraform. We were saying before about analytics code, infrastructure as code. And as we go, I'll start demonstrating a little bit about what it would take to get this thing stood up using Terraform code. And this block here on screen at the moment, excuse me, is really everything we need to get a fully managed Apache Kafka service running on Aiven. And one thing I'll point out here is that we are multi-cloud. As I said, you can deploy this onto any cloud platform that you like. And with Terraform, normally, if you want to build something on Amazon or build something on Google or Azure, the code you end up writing might look very different depending on the platform you're using. And it means that you need to learn a whole different set of resources and configs to use. But with Aiven, we've got a provider which is basically consistent across all the different clouds. So here you'll see cloud name Google Europe West 2. This is where I've chosen to deploy my stack here. If I wanted to move this thing to Amazon, I could just change that simple string there to AWS region, and the whole thing would just work as before. So we've got that really nice consistent layer across all the different clouds to deploy this thing nice and easily. Similarly for the Kafka connector, no code required, just a bit of config. And here, really we see the config embedded in that Terraform code. So we've got the connector class name that we are using. the endpoint you'll see in there, and really just that very simple statement to say we're inserting into a Kafka topic, we're reading from an MQTT topic with a different format, and then what data format we've chosen. We'll just use the JSON simple converter. And really that block of code there, probably 25 lines, is all you need to make that connection and get data flowing in to Kafka. Then what we'll see is a data record like this. And this is the raw data that we've got to work with. So as I mentioned, little things that I want to tweak about this, and this is where Flink comes in. So I'm going to pass this data now through Apache Flink to start pre-processing that stream. And we're going to do a few things here. We're going to join each record onto a small reference data set, which I've got sitting in a Postgres database. And this is really just a simple mapping of operator ID to name. And we'll also at the same time get rid of that nesting and write a flattened set of values to a different topic. So we'll keep it in JSON format, but we'll just remove that useless wrapper object around it and provide a nice flat set of fields. I could also do some simple transformations here if I wanted to. So for example, the Digitransit API reports the speed of the vehicles in meters per second, but maybe I prefer miles per hour or kilometers per hour or some other unit that I am more familiar with. And here would be a great place to write that new computed column alongside the original. So these transformations are all defined as SQL. There's no code to write here. We're defining Flink tables. We'll just tell our system about the schema that we're expecting. And these Flink tables act as overlays on top of wherever my raw data is. Essentially, that'll be a Kafka topic in the case of the main event stream, and Postgres in the case of my reference data table. But with that Flink table overlay on top, these kind of look like the same things, and we can start joining them however I like, and then right back to a third table I'll define, which sits on top of a second Kafka topic, which is the destination for my pre-processed records. Here's a Terraform fragment showing the Flink job setup. And the bulk of this really is that simple SQL statement that I am using to join the data and the reference data together. So it's very simple, it really doesn't take much explanation. We're inserting into a table, which is going to hold my pre-processed stream. We're selecting a whole bunch of columns from the source data, joining onto that reference on the common ID, which is that operator ID. And this query is not a one-time thing. Flink is going to be running this constantly in the background. Any new event that comes in will have that thing joined on and then pass forward onto the flattened data topic. What we'll see now is a record like this. So we can see we've got a new column, we've got our operator name, we've got a flat JSON structure now, not a wrapped one, not a nested one in an object. And this is starting to look really nice. So onto the final phase, we want to start doing some more in-depth querying, I suppose. So not on the stream, but want to start running analytics in bulk on this data set as we're collecting it. You can have this running for a few days, a few weeks, months, years, however long you want, really. You can retain that data into ClickHouse. This is my final destination for the data. And the main idea here is I want to be able to run queries against it, obviously over a nice backlog of data I've collected. But as new stuff is streaming in, I want that to be included in my query very, very quickly after it arrives. So ClickHouse has got really great Kafka integration right out of the box. So if I define a table here with an engine type of Kafka, this is going to be running a consumer group in the background and constantly reading new data arriving on whatever topic I told it to look at. So if you query that table, that Kafka engine table in ClickHouse, it's going to show you the latest records that you've consumed. But that's not really any good on its own, because then you can't query the same data twice. That consumer has already read the information. When it goes back to the table or the topic behind it, it won't pull that same thing again twice, unless you reset the consumer group details, which you won't want to do every time. So what we'll do instead is create a ClickHouse materialized view on top of that table. So now data is being constantly read from Kafka by ClickHouse in the background, trickling through into that materialized view, and now persisted in ClickHouse. So we can keep querying that thing over and over and over again. This is perhaps the only clunky part of the pipeline, because ClickHouse is in beta, as I mentioned. we haven't got the full integration here built into the Terraform provider yet. This is coming soon. So to create that mapping between ClickHouse and Kafka, to create that Kafka engine table, it's just a reasonably simple command we need to run at the moment on the Aiven command line client, just to give that table definition and make that thing work. So we're again listing the topics. We are saying that the data format we're expecting is row-based JSON and a Kafka consumer group name that we'll use to pull that data in. Once that table's there, creating a materialized view is a simple query as well. This time we're using a different engine, the proper engine for ClickHouse. And all we're doing is saying we'll select everything from our Kafka backed table, we'll order it by timestamp, and then persist that in our materialized view for forever. And then this table becomes the main place we will then go to run our analytics against. And I've got one here just to have a quick demo. So what am I doing here? Just selecting the kind of the average speed. So working out, if you've got a place to go, you're in Helsinki, you want to get there in a hurry, what's the best chance you've got with the different bus providers? We can see the average speeds range from a super speedy 26 miles an hour in the best case down to 15 miles an hour in the worst. So if you're in a huge rush, maybe none of these will be a good option. But if you are interested, then it gives you a little bit more information to base your decision on. And you can try this yourself very easily. So all the code, you'll need a little bit more code than I've shown on the slides, but the entire thing, so the end-to-end data pipeline that I've run through today, probably takes about 400 lines of Terraform, and that will build the entire architecture, including all the integrations between the different services. You'll get your Kafka Connect set up, pulling data from that endpoint, as well as all the Flink table and SQL definitions to do the pre-processing, and then landing into ClickHouse at the end. You can sign up for Aiven on our console. 30-day free trial, $300 credit as standard, no obligation, no credit card required, nothing like that. Just to have a play around. So yeah, please have a go. Grab the code, see what you can build. That is the end of the presentation. Thank you very much for your attention so far, and sorry about the interruption in the middle. My hotel Wi-Fi letting me down in a big way. So Shu, shall I read out the questions?
Yeah, I think, I can read the questions. There are a couple of questions that have come through. I was also going to say that I'm probably going to take a bus home after this, this evening after work anyway.
I'm taking the plane home after work tonight.
Yes, you are. Okay.
My private. So.
Your private. Did you say private jet?
No.
No.
I wish.
Sorry,
one day.
I'm hearing things. Okay. First question. How scalable is this? That's the question.
Oh, it's massively scalable. Both Kafka and ClickHouse can scale hugely. I think the data set I'm reading, it was maybe 2 million events per day. And I can see a case in ClickHouse where you can start building up a backlog of months and years, maybe even years and years and years of that data to do some really great analytics against a historical data set. So yeah, Kafka and ClickHouse can scale probably as much as you need them to. The scale of these technologies are being used already by companies out there is massive, like a high hundreds of terabytes, if not petabytes. So incredibly scalable technologies both.
Yeah, good to know. The second question goes, can I configure it while it's running?
Yes, you can. So in the case of Terraform, what you can do is just go and make changes to your Terraform code, plan and apply that. And the Aiven platform is going to make those changes for you, fully automated, and the service will just keep running. Depending on what you change, it might book in a little restart, like your Flink job might just restart with the new, if you change the query, for instance, that you're running, but it'll just carry on where it left off. And Kafka Connect, again, very easy to configure as on the fly. It's got a REST API. You can just start posting new configs and new stuff to that. So yeah, in all cases, probably the tools that I'm using for this pipeline, they can all be configured on the fly and changed very easily through the Terraform code or directly over the APIs that we do expose.
Sounds good. There's another question that just came through here. What can this setup be used for, say, in like the e-commerce vertical?
Wow, for anything really. It's a very flexible set of tools that you could use for any reason. For e-commerce, I can see, the reason ClickHouse was invented, I think, was for clickstream analysis, and that's a great use case for e-commerce. So you're really tracking the journeys of people clicking around a website and then pulling that data into a database to analyze and spot trends and patterns and recommend products and journeys, that kind of idea. But yeah, none of this stuff is specific to any one use case or vertical. I've chosen a data feed based on vehicles moving around, but
yeah,
the sky's the limit, really. We've got a huge range of other Kafka connectors. So you don't want MQTT data, then that's fine. You can pull data in from different databases. We've got 20 or so different source connectors that you can choose from. So yeah, very flexible is the answer, I'd say.
Gotcha. And then it seems like we have a last question anyway. There are a few questions that came through. Okay, not the last question now. Can I transform the data in Flight for Snowflake?
Yeah, you can. So obviously we were landing in ClickHouse this time, but I think in the case of Snowflake, what you need to do is we'd be transforming the data in Flight using Flink, getting it back into Kafka as we did before, but then it'd be Kafka Connect again on the way out using our Snowflake data sync connector. So you transform the data any way you'd like for Snowflake, and then the managed connector for Snowflake is the way you'd get it out into that system too.
Yeah. And then the last question, there was this, and I heard about this too, the Catch the Bus challenge. Is that challenge still ongoing?
That was a challenge we had for the Big Data London conference last week.
Right.
I believe it's still ongoing. I don't know. I took the slide out because I wasn't sure if
I'll have to double check that. But probably we'll have to double check that. I'll get back to you. But these are all the questions that we have actually. Dave, thank you. It's funny because after you came back on, every time you had a bit of a pause, I was like, I held my breath for a bit.
I kept checking my phone here on the desk. Am I talking into the air, or is anyone out there?
No, I was listening to you. There is someone out there for sure.
At least one out there.
But yeah, thanks everyone for tuning in to today's webinar. If you're wondering, the webinar will be made available on demand, and you can watch Dave's awesome recap and my awkward scenes. In case you're interested, I'll to forward this to any of your anyone that might be interested. But anyway, if you have any suggestions for future topics, do reach out to us. We're always open for that feedback. With that said, thank you again, and from myself, Dave, and on behalf of the whole Aiven team, have a good rest of your day. Thanks, guys. Thanks, Dave.
Thank you all.